Good day, dear viewers at home. You are welcome to episode 39 under circle geometry. We are still on circle geometry, theorem 8. Today we want to look at two chords which are not parallel to each other, drawn in a circle. It will always intersect at a point inside or outside a circle, no matter how you draw it. And this one can be proved via construction. Let's try to look at what we are saying. If we have chord PT by construction, if we have chord PT which is not parallel to another chord, assuming we have this chord PT, now if we try to get another chord RS, no matter how we draw it, we always intersect at a point. This can only be proved by construction. So this is the point of intersection of chord RS and PT, which are not parallel to each other. We can as well have this chord PT again by construction. We have the straight line here. Let's make this one dotted line. No matter how you draw it, provided the two chords drawn to that circle are not parallel to each other, then they have to meet at a point, either inside or outside that circle. Can you see? You can draw this. That is the theorem 8. As we draw it, they can meet at a point. Let's call this one Q. So what we are saying is that if you draw two chords and they are not parallel to each other, they will always intersect at a point, either inside or outside a circle. Now let us move to theorem 9. Theorem 9 states that two tangents to a circle meeting at a point outside the circle are always equal in length. What we want to show now is we want to look at tangent PQ being equal to tangent RQ. So we are going to make some little construction in order to ascertain that. Let's assume that we join P to the center of this circle. If we join P to the center of this circle and also join R to the center of the circle, let's call the center O. Then we draw a straight line to come and join that line at point Q. What we are saying is that we want to prove that line PQ is equal to RQ. Let us consider triangle. From our previous theory, we say that if we draw a line from the center of the circle joining a tangent, it must be at 90 degrees. Likewise, this one will be at 90 degrees, showing that this long side OQ is the hypotenuse. So radius will always be equal to radius. So consider triangle OPQ. If we consider triangle OPQ, then hypotenuse squared, that is from Pythagoras theorem, hypotenuse squared, that is OQ, should be equal to opposite squared OP squared plus opposite squared, PQ. Don't forget we want to prove that PQ is equal to RQ. So if we consider that, we can prove that. The same thing also applies if we consider triangle OQR. Then we also have it as OQ again is equal to OR square plus P plus RQ square. Now, we know that our OP should be equal to OR. Why? Radius of the circle. So if that is the case, that means OQ square should always be equal to OQ squared. If that is the case, that means OP squared plus PQ squared should be equal to OR squared plus RQ squared. Since that is the case, that means once we say that OP equal to OR, then we can say that OP, which we change to OR square plus PQ squared should be equal to OR squared plus RQ squared. So if we cancel this one out, then we have PQ squared equals to RQ squared. So if we square root both sides now, then PQ will be equal to RQ. Proof. So by the next episode, we are going to look at some working examples pertaining to the circle theory. We have dealt with the 9th theory. Now, next episode, we are going to look at some wire questions, NECO questions, and so on. Please, you help us share and subscribe to our channel. Thank you.